get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so awesome.
are an open culture that
It's actually a big piece of
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Good afternoon, good morning, good evening. Welcome to the Level Up Hour, where we talk about all things containers, Kubernetes, and OpenShift. I'm your host, Randy Russell, and I'm joined by my co-hosts, Scott McBrien and Jafar Charibi. How are you this morning, gentlemen?
Doing well, Randy. Thank you.
So we have a great episode, I think, today on a topic that is sort of a back to the future. And just want to remind everybody, like, subscribe, and share so everybody knows that we're out here doing the Level Up Hour. Today we are going to talk about SELinux and containers. And the reason that this strikes me as a back to the future kind of thing is that for those with a long memory, you might recall that OpenShift began as an SELinux trick, right? Am I wrong?
Well, I mean, we definitely use it in how we segment off containers and keep their workspaces separate for sure.
Well, but the actual, before we actually did it as a container orchestration thing using Kubernetes, it actually was an SELinux built product very, very early in its life cycle, way back, years. But now we have a different interest in it, right? But it's the same interest that we have in general with SELinux. So maybe tell us a little bit about what SELinux is before I go chasing after this.
While you're opining.
Well, I'm opining because I've got a lot of opining.
So SELinux was added to the Red Hat Enterprise Linux distribution as one of the standard features in Red Hat Enterprise Linux 4. So it's been with us for a long time. And its goal is to change how processes and users interact with resources on the system. And there's a whole vast policy rule set that determines those rules of engagement between processes and users, or processes and files, or files and users, or ports and files, or ports and users and ports and processes. It's immensely complex. And I will warn you in advance, the demos that we're going to go through today, and Randy, you got to see this morning, it's a lot of command line. So we're going to get into the weeds a little bit on SELinux.
Right. Well, so one of the things that I think that is notable here is that SELinux is sort of at the heart of RHEL since RHEL 4, okay? And I think when it was first introduced, it actually caught a lot of people by surprise. The scripts that you had lovingly curated, for years under previous releases might not have worked. Applications might not have worked, but it's because it really fundamentally alters, as you said, everything: files, processes, users. What users the processes are running under, what files a particular user running a particular process can run under. So it's very all-encompassing, but it's always possible to be the executioner and just come in and go no to SELinux, right?
Yeah, and we're making that harder and harder to do. And I will, full transparency, when we introduced SELinux in RHEL 4, its default policies were draconian. And it did cause interference with a lot of functions. And so I think in the RHEL 4 days, 15 years ago, it was very valid, especially because there wasn't a lot of documentation and tooling and a whole bunch of other stuff to just turn it off. But we don't do that anymore. In fact, many of your RHEL systems, if you've just installed one and are running it, probably have it on and enforcing by default, and you don't notice it because of all the improvements we've made to the policies and the interactions between things over the intervening 15 years.
Well, it actually, I'm going to say, I think not only is it improvements that we've made, but I think that it also made a lot of people give a second thought to a lot of things that they had maybe done and implemented prior to the advent of SELinux that made them realize, well, okay, maybe it's not a good idea for this to run under this user, or for, you know, this particular process to have this degree of file system access. So I think that it, in a sense, it was the rising tide that lifted all boats, and we rose the tide a bit by trying to address it and make it a lot more just, it works, it's transparent, it's not a problem. But I think it also affected people's behavior. I think it made a lot of people rethink how they did things, which kind of takes us to the present day, right? And containers.
Yeah. Well, it certainly interacts with containers. In fact, there's several SELinux types that go along with containers, and we'll see a little bit about that today. And then we also added some tools, specifically one that we'll take a look at in the second demo, to create custom policy modules to insert into your policy for specific container contexts.
Sounds good. Jafar, are you ready for some command line wizardry here?
Yeah, sure. Let's go ahead. So,
All right.
Stand back.
That's right. Let's get ready. Got to loosen up. So what we're looking at is a Red Hat Enterprise Linux 8.5 system. It does have SELinux enabled and running. You can just check that with the SE status. So it's enabled. It's using a policy called the targeted policy, which is the normal one that we use for Red Hat Enterprise Linux these days. And so it's there. And if you've not seen SELinux before, one of the other Red Hat Enterprise Linux shows touches on some of the basics for it. And just the rules of the road are put things where we expect, and know that SELinux could be stopping things, so know where to look to troubleshoot. All right. So I think those are the two first like pillars of working with SELinux. So I'm just going to become a normal user, and we're going to do some rootless container stuff. So I'm just going to build a container real quick. And to make my life a little bit easier, I'm going to copy and paste from a document. All right, so I'm going to download the RHEL 8 universal base image, because that's going to be my starting point for making a very simple container. All right, I'm going to take and, oops, let's try this again. Install Apache into this container. So it's just going to run a web server, right? Super simple. And then I'm going to do a little bit of extra stuff to make sure that Apache is running when we start the container. Sorry, I'm having a very sloppy mousing today, apparently.
Hey, come on, we're on the keyboard. It's all about keyboard today.
We'll get there. Nobody wants to hear
other than the copy and paste that you're doing on the keyboard.
All right. So with this systemctl, I just made it so that when the container boots, Apache will start. And then I'm going to make sure that that's the service that, oh man, I did it again. Going to make sure that's the service that starts and attaches to port 80 in the container. Maybe I just need to be better at where I put my cursor. There we go. Okay, so now we've got a very simple Apache container that will start Apache when the container boots. So let's go ahead and commit this working container to a container image. All right, so if I do a podman images, right, there's this EL HTTPD container that I made that contains the Apache server. And we can spin it up. And so if you're seeing Podman for the first time, we're running a container in detached mode. We're assigning a port assignment to it. So connections that come in on port 8080 of the host will be redirected to the container's port 80, which is where we have Apache sitting there and listening, thanks to our configuration inside the container earlier. So there we go. And if we do a Podman PS, right there's my running container called Musing Gates, apparently. So what you may not know is that as we invoked this container, a whole bunch of SELinux stuff started. So if we use ps auxz, right, you'll notice that all of the SELinux commands have a capital Z to identify that you want the extended SELinux attributes to also be included in the output of the command. And we're just going to grep httpd. So these processes that are running in my container right here, what's interesting about them is with this Z output, I get this field of SELinux stuff, right? And this field of SELinux stuff tells me the contexts that this program is running with. Earlier, we took a look at what the SELinux policy was. It was the targeted policy. And the targeted policy typically looks at the third field in this set of contexts, this guy, for making decisions. But what's interesting about containers is that we also get this additional set of fields that is not usually set on processes on the system. So just for reference, the fields of this output are the user field, that's the system U, the role, that's the system R, the type, so we're a container underscore init underscore T, the sensitivity, and then this last bit is called the category. And this is assigned in a container, whereas if we look at other processes on the system, right, these other processes, we don't see that category set, right? Also, if we invoke another container of this same image, now we have two. And if I look at my same output, what we see is that one container has these categories assigned to it, and the other containers processes have these containers assigned to, or categories assigned to it. And so this category assignment is actually how we keep the different containers separate so that they don't mash on each other or incorrectly align themselves to resources that the other one has, right? Because according to the system, if we're just to look at like basic Linux process management, these are running HTTPD processes. And we would look at things like ownerships or permissions to determine their access to things. But thanks to SELinux, we now have this additional dimension of control. And the way that we identify individual containers to control them even more tightly is this assigned category parameter that's on their processes.
All right, so pause for a moment because we had a question. I've actually had a couple of questions today, and one of them concerned, should we use the uni init container for these sorts of use cases?
UBI init?
I think that
I
might.
mean, UBI init?
Benjamin wrote uni init, but I think it probably means UB init. Benjamin?
Okay. All right, so I think that's a typo. Oh, it's Ben Blasco. Oh, that guy. Okay, so it is a typo. I think he's talking about UBI init. So
yeah, because I didn't know what it was.
There are several flavors of universal base image, and we've talked about that on a previous show. And we can use the UBI standard image like we're doing here, which is fine. Like clearly my process is running, it's listening on the right ports. The differential between UBI standard and UBI init is if instead we had more complex processes running. So maybe we had a database running in this container too. So there we can't just start up Apache as the base process when the container starts. We need to start up both Apache and the database. And that would be a reason why you would want to use the UBI init flavor, which includes a full system implementation, so that you can write the unit files and start services and control like the order in which they start and things like that. So if you're looking at simple application containerization, UBI standard works really well, which is the one I used. If you're looking at taking an existing monolith or a set of services that you would normally install on a virtual machine or a server, and you want to run that collection together, just like you would on a normal system, that's where you would look at something like UBI init. It increases your base image size because it includes that full systemd implementation, but it allows you to have that more complexity and flexibility of using the full systemd implementation.
Well, and hopefully that provides some clarity to that question. So back to the demo. Where next do we go with this?
So just to like round out that SELinux is there and doing things. So let me go back to being root, because I just want to show you.
Break some rules. We're gonna test
I just want to show you the rules.
Okay.
So I installed a package called SETools-console before the show, and that gives me this command called SESearch. And I'm going to look at all the rules, but I'm really only interested in those rules that contain container init. Right? These are the ones that would affect that process that we were looking at that was running with the type container init t. And there's going to be a lot of them. So the rules that we've got are highly complex. In fact, let me take that and word count it. Right? It's highly complex, and these rules determine what our container init type process is allowed to do on the system. Right? So just the container init type, there's 99 rules. If I take away that filter and just look at all the rules in the SELinux policy, it's going to be many. So I don't want to get into all the details about, excuse me, about how we write rules and things like that. I think that's probably below the fold for our discussion today, and we don't have 4 days of which to talk about it all. But just real quick, if you're interested in reading a little bit on your own, so let's take a look at this rule right here. So what this rule that I've highlighted says is that container init type processes are allowed to attach to Unix datagram sockets, right? So they can open or use UDP-based network connections. And when they attach to those UDP sockets, they're allowed to accept, append, bind, connect, create, get attribute, get opt, IO control, lock them, memory map for them, and a variety of other parameters, right? So what we're looking at is whether it's an allow or deny, the context that this rule applies to, the function that this rule controls, Unix dgram socket, and then when a process of this type tries to do an activity of this type, here are the actual things it's allowed to do. So we can see maybe a little bit smaller list. Oh, like here's one where it's allowed only one activity. So if a container init t attaches to or tries to use peer, I don't know, system call maybe, it can only receive v. That's the only thing it's allowed to do. So again, we don't want to kind of jump into the craziness of SELinux rule manufacturing. In fact, we have a tool to help us do that. So that's the second demo. But I'll pause there. Anything else you want to bring up, Randy, before we move on?
Well, you know what? So far, this is familiar looking stuff. If you have delved into SELinux, it's SELinux in a container. Are there any sort of hurdles or gotchas that people might need to know if they're working in the container environment that they might not have encountered working more, just on within regular OS and SELinux?
I think that they, if they're familiar with SELinux on RHEL, then transitioning to SELinux managed containers or SELinux interactions between containers is a pretty straightforward transition. The problem is, I think a lot of people work in an environment where they don't have SELinux. Either they're on another Linux or they're using tools to build and manage their containers that don't interact with SELinux. And so they take this from their development environment or from this other thing that they're working with, and they send it to a repository. And somebody on RHEL downloads it from the repository and tries to run it, and it all comes crashing down on them.
So
So I think
sometimes this is going to be necessary as a troubleshooting measure for a container that you received elsewhere.
right, and that's where I think our second demo will get into it. So let me real quick build essentially the same thing, but in Roots local podman repository. Or so we're just going to make another one of these EL HTTPD containers. And see, Jafar is cringing because he's like, if only you put it in the registry, you goon.
It's fine, no worries. We are open to everything here. But yeah, what I'd like to mention at some point is that we do provide also this kind of out-of-the-box features for OpenShift in terms of SELinux rules and configurations. But yeah, let's keep that a little bit later, for a bit later. And apologies for the people on the stream. I'm a bit sick today, so it's better if I don't show my camera.
Well, get
All
better
right.
soon.
Thank you very much.
So here we're going to invoke our container a little bit differently. Number one, you'll notice that I'm doing it as root. So we're not going to be running rootless for this example because doing things like adding your own policy is something that requires root ability. And rather than trying to figure out like how to play between the root account and user accounts, I just said, well, for time's sake and simplicity, let's cut out the middleman there. All right, so I'm going to run my container. We're going to store its container ID that gets returned when Podman invokes it into this variable called container. But this time, instead of just running the Apache container and binding it to a port, we also do a couple of additional things. We provide volume mapping between the container and the host. So inside the container, when somebody accesses /home, that will access the host's /home, and they'll be given read-only access to that directory. And when somebody in the container accesses var spool, then that will access the host's var spool, and for that, containers should be given read-write permission to that directory. All right, so here it is, and if I do a podman ps, right, there's my running container, agitated visvestraria, whatever that is. And so we're running, except it's not operating the way that one would expect. So notice there were no errors on the command line there, right? It's running and everything looks fine until you try to work with it a little bit closely. So I'm going to connect to the container and just have it invoke a bash shell so I can interact with that running container. All right, so here we are inside my container. And if I look at home, remember, this was set up as a volume pass-through, so I should be able to see the contents of /home on the container host. But no. And remember that I said we should also pass through var spool. So when I access var spool inside the container, it should pass through the container host var spool, and I should have read and write access to that. But no. And so this is actually SELinux rearing its head and stopping the container from doing something that maybe it shouldn't do. So let me go out of my container here. And the first thing, remember, way back at the beginning of the episode, I said the two main things for SELinux is put things where we expect and know where to look to troubleshoot if there are problems. All right. So here's the problem. We didn't put things where we expect. Why are containers accessing things in var spool? Why are containers accessing things in someone's home directory? That's unusual activity for a container to be given access to. And so the default SELinux rules are like, nope, sorry, buddy, no dice on that. So now that we've broken the first rule of put things where we expect, we need to leverage our understanding of SELinux and use the second rule, which is know where to go when things go wrong. All right, so I'm going to use Teamlux here. And I'm going to create 2 screens. And in one of them, I'm going to go back into that bash. Whoops. Sorry. Teamlux doesn't like me. 1 second. All right, I'm going to kill off this container, then start Teamlux, and then run the container again, because that way my variable will actually work. Or I guess I could have exported it, but shell. Control B quote. All right. So we're going to invoke another version of this container. Okay. And I'm going to connect to that container. And in my other Teamlux window, I'm still on the container host, and I'm going to tail-f var log messages. All right, so we see some error messages from beforehand, but I'm going to put some white space in there so we can get some fresh data. And I'm going to go back into my container image. I'm going to do that ls again. So I said ls home, which according to the container invocation should work, but we know it's not working. And no. And then we're going to take a look at var spool, which according to the container invocation should work, but we know it's not working. And as I'm doing these activities, you'll notice that some stuff is going into the varlog messages file. And that stuff is specific SELinux error messages. Right? And so it's telling me that right here, this is probably the most interesting message, straight and to the point. SELinux is preventing our container from read access on the directory var spool. And then it gives us some stuff that we can do if we wanted to resolve that with audit to allow. So we know that it's an SELinux problem.
Yep.
Because we're doing things, we're seeing SELinux problems. All right, so to further drive that point home, I'm going to go back to being root on my host, and I'm going to turn off SELinux, right, which is, something that we don't normally do.
Kids, don't try this at home.
Well, no, I mean, it's a valid troubleshooting methodology.
Just kidding.
You wouldn't want to do this on a production system where you might have other things that if you turn off SELinux now, like expose some things you didn't mean to on the system. But
I was just having
what I wanted to do,
some fun. Okay. But yes, Scott is absolutely correct. This is, if it was something you shouldn't do it, you wouldn't be able to do it. But you will need to do this sometimes, and it's for exactly the kind of thing that Scott's doing now, where it's a diagnostic thing. Well, okay, let me confirm that it is in fact what I'm thinking it is, which is SELinux. This is the easiest way to do that.
All right, and
I'm on the edge of my seat now, Scott.
well, my box became ineffective. Let me refresh this real quick. All right, tmux. Oh, yeah, my box just got too busy. Okay. Cool. But one of the magic things of tmux, right? You can reattach to your session in case you lose it. All right, so let's try this. So we turned off SELinux, and now if I list home, as though by magic, I now get content. Right? If I touch a file in var spool, as though by magic, it's there, right? And we can verify that that's actually working by going back up to my host. Right? And there's that file that I just created from within my container. But if I re-enable SELinux,
Well, wait. Before you do that, let's do a
okay,
list with the SELinux attributes and see what. Yeah,
so there it is.
yeah.
All right, so let's enable SELinux, reinforce it, or set it back to enforcing mode. Okay. And when we turn it back to enforcing mode, we expect if I try to look at home, it fails again, right? So we've diagnosed that SELinux is really the problem. We saw the error messages that were happening in context. Then when we turned it off, all of our problems were magically solved. We turned it back on. Oh gosh, it was terrible again. And at this point, the less seasoned administrator would be like, "I'll just turn it off," right? But we're not less seasoned administrators. We're people that know what we're doing. So what we're going to do instead is we're going to create a policy extension that will allow our container to actually do the things that we intended to do. So I'm back on my my host over here, and let me go up to my top window. I'm going to install a package. Now, in North America, you'd probably pronounce this Utica. But if you were a Czech engineer, you would pronounce it Udica, which apparently is Czech for fishing rod. Because if you teach a man to fish, you feed him for a lifetime.
Oh my God.
Yeah, fun times. Your Czech trivia of the day. All right, so I've installed this Udica module here, and what we're going to do is we are going to create an SELinux extension to apply to this container. So what I'm going to do is I'm going to pull the JSON definition for this running container, and I'm going to pass that to Udica to make a special policy extension. So we're going to do a podman inspect. Inspect. And that results in this container JSON, which is like all these definitions around what this thing does. But what's important about it is that in this definition, it's going to have information like the fact that this container was given pass-through access to home, and this container was given read-write pass-through access to var spool. That's what's in this JSON that we care about. Also, it's going to have things like what port it was attached to and some other stuff. So next, what we're going to do is we're going to call Uditsa. And we're going to tell it to make an SELinux policy extension based off this container. And we're going to create a special type in the SELinux policy extension for this type of container. It's .app. All right, so it has successfully done that. And it says in the output here, like, hey, don't forget to load your extension into the SELinux policy. And then also, when you start your container, you're going to have to tell the container that it needs to identify itself as this special kind of process so that it is able to be covered under this rule set that you just created. All right, so let's go ahead and do what it suggests, which is insert our policy extension. And then we're going to have to run our container again, but this time we're going to have to add a couple of extra options to it to make sure that it is of this type. All right. So let me kill off that one that we're running. There are two of them, so let's kill off both of them. All right. Now for the grand finale. So we're going to invoke our container again, and we're going to do the same volume pass-throughs that we did before. But notice that we also add on these two additional parameters. We're using an extra security option, and we're telling it the label to assign to this container's processes. So there we go. If I do a pubman ps, we're running. Reverent Shirley is our magical special container here. All right, so let's go into this.
By the way, the container names are especially wonderful this morning.
They are. All right, so here I am on my container. All right, let me go back up to my other window so we can verify that there is nothing up my sleeves. So we're enforcing, and we're using the same policy as before. But now, if I ls home, it works. And now, if I touch a file, var spool container file 2, it works. Right, so there's the file that was created from my container.
And again, give me the long listing, man.
Okay. Hold on. Let's do that. There's my container file 2, right there.
Yep.
Okay. And so the magic that's happening here is those additional policy extensions. So let me get out of my container, and we'll go back to full screen so we can see it a little bit easier. All right. So if I do an SE search -A, remember we used this tool earlier to look for things that were container init type and the rules that went along with them. But now we're going to look for rules that are Scott app process. Maybe. Nope, that didn't give me what I wanted. Let's change it a little bit. Add some more credentials on here. Let's do a type user home T. If that gives me what I want. There we go. So this one right here got added by adding that UDITSA generated extension. And it says that when things are running as Scott app process type, they are allowed access to user home directory type files. And when they access user home directory type files, they're allowed to do these things. And notice they're allowed to get attributes. So they can do things like an ls. They can work with it with IO control. They can lock files. They can open files. They can read contents. And they can search through files. But notice what's missing from there? Write files. So I was able to look at my volume pass-through of that invocation for my container, saw that the volume pass-through was read-only, and then it set up the SELinux rules to only permit that read-only access to that directory that we wanted. And likewise, if we look for the var spool directory, so right here, same thing. Scott app process type running processes are given access to var spool type directories. And then here's the things they can do. Add name means that they can do things like create new files in there. There's also a write, right? So I can actually like put the data in the directory in my files. So that's what we did with that UDITSA thing, right? So super complex SELinux became magically delicious by having a container tool, UDITSA, create some container-specific rules for our stuff, right? And now we can invoke any container with the Scott app type, and it will be covered under these rules that we've added into the policy.
Well, I'm liking the Uditsa, and I like the story too. That's a great name. So, Jafar, see if you can, drag yourself out of your sickbed for a moment and share with us, are these things that when you're working within the OpenShift environment are things that you have to consider there as well? Or are they things that, in a sense, OpenShift is already taken care of for you?
Yeah, so that's a good question, and actually one of the great benefits of using RHEL as a foundation for OpenShift, and when I say RHEL, it's in the broad sense, because we used to have RHEL before, and with OpenShift 4 we switched to Red Hat CoreOS, which basically shares the same kernel as RHEL. And we do enforce SELinux by default, which prevents from a lot of bad things from happening. So I think Stephanie has shared the link on the chat. And so one of the great things is that all of those SELinux rules are already also implemented for OpenShift, for containers to be able to run safely. and not be able to have too many capabilities when running on OpenShift by default. So we have what we call security context constraints, which are ways for us to determine basically what containers are allowed to do by default. So we do provide different types of what we call SCCs, and I'm going to share a link to the OpenShift documentation that explains basically what it does. And so, yeah, it does provide all of those very rich um, policies, and they are already implemented for OpenShift. And as an administrator, you can change the attributions and define new security SCCs and such things. But they do also control what happens with the SELinux context, etc. So that's one of the, from a security standpoint, one of the great things that OpenShift provides. And yeah, I'll invite you to check into more in depth what this does. So I'm going to share a link to the OpenShift documentation.
Yeah. Well, great. So back to you, Scott. Some closing thoughts, perhaps, on the world of SELinux and containers.
So, as Jafar pointed out, like if you're using OpenShift, all of this stuff just kind of happens. And just like we manage the policies for RHEL in a way that, like mostly the services that work with RHEL just kind of work. Same thing is true for OpenShift, right? So we take care of that automatically in that product. So when you have to get into the bowels of SELinux is when you're using RHEL natively as a container host and you have more eclectic container activities that you're trying to do, where you're trying to pass through host accesses or host resources to your container. That's where you're going to probably run into some bumpiness and have to use some of these SELinux troubleshooting techniques that we talked about today, and tools like Uditsa to help just kind of smooth over those problems. You could also use audit to allow, which is what the SELinux error messages suggested in Varlog messages. That would work too. But there you would make that the case for all containers, not just ones of this type, like we did with our Uditsa policy extension that we added.
No, Stuart. No, no.
Man, somebody
We had a
just
comment.
loves
Set
to.
it for us. There's always going to be somebody. There's always going to be somebody. Yes. Set it for 0. No. Actually, in the meeting notes, there was one other thing that was mentioned, and that was rootless containers. And are there some unique challenges associated with that?
So, yes.
In brief.
There's a reason why my second demo was being done as root, because I couldn't figure out how to make it work for rootless users. And that's mostly because, like, can rootless users extend the SELinux policy? Not really. Can rootless users do things when they invoke their containers to make sure that they have the right policy set? I was having trouble with that. So it's not to say that it can't be done. I'm just not smart enough to do it, apparently. Or it's something that needs to be further enhanced. There's a couple weird things that happen with rootless containers. And I know the Podman team specifically has been working just feverishly to try and resolve some of those things around things like namespaces and some other stuff. And they're getting better. They're getting incrementally better. And you should see some changes in Podman 4, which will ease some of those, not all of them. And there's actually a doc. One second, let me look it up.
Well, no, sir, I have dropped it in the chat. If it's the one that was in the meeting notes.
It is so that one is an excellent article about rootless things from Dan Walsh.
There you go.
The other thing I wanted to put in was Dan keeps a running tally of all of the annoyances of rootless that they want to resolve but are not yet resolved in the community GitHub for Podman. Yeah, this is it right here. So I'll put this in the chat too. Maybe. There we go. So these are the things that he knows about that don't quite work the way one would like, that they're going to work on resolving. But so when you were doing rootless stuff, I always, if I run into weird problems, I always check here first to make sure that it's not a known weird problem. Because yeah, there's still some weirdness there.
Yep. Well, maybe that's something we can consider in a future episode. But for now, unless we have some additional questions or comments, we had a lot of comments today. fewer questions, more comments, like setting force 0. No, I say. Doesn't look like we have any more. So I think with that, we can call it another one. So everybody, please do remember to like, subscribe, and share. Let everybody know we're here approximately every other Wednesday morning in U.S. Eastern Time. And I guess I will say thank you for joining. And gentlemen, thank you for the show today. Bye-bye.
Bye, everyone.
Thank you, everyone. Bye-bye.